हेलो। आज की जो हमारी टुडेज वीडियो वी विल डिस्कस अबाउट दिस स्ट्रेस स्ट्रेन डायग्राम फॉर कास्ट आयरन मटेरियल. This in brown color you can see this is the stress strain diagram for cast iron. In this third quadrant it is compression, and in the first quadrant it is tension or it is expansion. In cast iron, the maximum stress that a material can handle up to yield point, there is no you can say premature indication that material is going to fail because there is no yield point in case of cast iron. So in case of cast iron, the maximum stress at which material will fail, this is sigma y. I am calling it sigma y or sigma u. So this stress is equal to 165 megapascal in case of tension. However, in case of compression, sigma y is equal to 485 megapascal. So it means cast iron is more strong in compression, right? More strong in compression. So it is very much clear now. Now in tension it is only 165 megapascal. So it is clear from here. Cast iron, because cast iron is one which can be casted. So cast iron is used where more compression forces are required, like beds of machine tools. जैसे for example, the lathe machine, the frame of lathe machine is made of cast iron and all that, right? So because carbon percentage in cast iron is more, carbon percentage is more, so the cast iron is brittle material. Cast iron is strong in compression, cast iron is a brittle material. Cast iron is used in making beds of the machine tools, sorry. And but cast iron is weak in tension, so any element which if you design it with cast iron, then it will fail in tension easily at a very small amount of load. To remember what is the value of Young's modulus of cast iron, you can remember this thumb rule, that E of steel divided by 2 is approximately equal to E of cast iron. Now in case of aluminium, here I have also shown this stress strain diagram for the aluminium, right? Aluminium is a ductile material, but actual yielding in aluminium is not very much clear. Like here we know that sigma y is equal to this, but in case of aluminium it is not very clear. So we use offset method to find out what will be the yielding point for this aluminium material. For that, for example, 0.2% we make a line, and in initial this particular line, cyan color, this particular line, we draw a parallel line to this like this, and wherever it cut this particular line, we call that this is the yield stress of aluminium. But it is not clear, this is an offset method. So we call that at this much fracture strain aluminium will fail. We will not say that at this particular stress it will fail, because that point is not clear on stress strain diagram. We say that at this much fracture strain aluminium will fail, right? So this method is known as the offset method, which is used to find the yield point of the aluminium. To remember what will be the aluminium's E, you can remember that it will be 1/3 of the steel. So these are the thumb rule. It will be approximately equal to, not equal to, approximately equal to this. Now note that higher the value of E, that is Young's modulus, more elastic is the material. So line of proportional limit is more near to y-axis. This particular line, if I draw again like this, and if this material is more elastic, this material is less elastic than this material is less elastic than this material. So as this line goes as near to this y-axis, which is stress line, the material will be more elastic, right? it means the small value of strain will have significant resistance from the material to that strain. Are you getting my point? I'll repeat again, that in this particular material only this much strain, very small amount of strain, this much strain will create much more resistance. In this material, this much stress is produced by this much strain. However, in this material, this particular material, this much stress is produced by this much strain. So what it means? It means the response of the material to the strain. If the E of the material, that is elastic limit or the Young's modulus of elasticity of the material, is more, the material is more sensitive to fracture strain, to strain, not fracture strain, to strain. A small amount of strain, material will react immediately it will produce the stress. However, for less value of E, the line of proportionality is away from y-axis, as I shown over here. Hence the resistance or the reaction or the response of the material to small strain is less. Example over there, one more example is there, like natural rubber. In case of natural rubber, proportional limit is only up to this point, and after that it is non-linear elastic limit. So the response is more. Rubber can be expanded more than steel. So the resistance offered by steel is more in comparison to resistance offered by natural rubber. So I hope this in this lecture you understood what is cast iron stress strain diagram, what is aluminium strain diagram, what are the relationships between uh, Young's modulus of elasticity of steel and cast iron and aluminium, and what is the value of E, and how the slope of the from the slope of stress strain diagram you can understand what will be its effect on elasticity. Okay, thank you.